In this video, I want to introduce the periodic table and show you why I consider it to be the best legal cheat sheet that you could ever have for a science. So here's the modern periodic table. It was put together by a guy named Dmitry Mendeleev. Now Mendeleev, as we saw in the Hunting the Elements video, was a Russian scientist, and his periodic table looked nothing like the modern periodic table. But what he actually discovered was the law of periodicity, which is where we get the periodic name in the table. And the law of periodicity, I like to just paraphrase as, periodically you come across something that behaves like something else. So what we have is this arrangement of columns and rows. So the columns are groups or families. So groups or families for the column. The rows are known as periods, hence the periodic table. So we've got some divisions within the periodic table. And chief among these divisions is the splits between the A's and the B's. So here we have our B's, and here we have our A's. Now these A's and B's refer to the type of group we're dealing with. So the blue ones, or the A groups, are what we call the main group elements. And the guys in red, which also include this little breakout table here, are known as the transition elements, or the transition metals, because they transition from one main group to the other main group. Now additionally, we can see that we've got the green ones here and the blue ones here, and then the gray there. The green are metals, and you can see that most of the periodic table consists of metals. The nonmetals, or the blue elements here, are a smaller subgroup of the elements and don't behave like metals. So metals are shiny, they're conductive of heat and electricity, they're malleable and ductile. Malleable means you can hit it with a hammer and it deforms. Ductile means we can spread it into wires, so malleable and ductile. Whereas nonmetals are not malleable or ductile, they are brittle. They're not good conductors of heat or electricity. They're not shiny, they're dull. So there's a definite difference. Now, you can also see that there's this staircase that we go down where we are bounded on the sides by the gray, with the exception being aluminum. Aluminum is a metal. Now, these gray ones are metalloids. Now, the metalloids have properties between a metal and a nonmetal. They're usually shiny, but they're not good conductors. They're not bad conductors, but they're not good conductors. They're semiconductors. So they're in between the properties. Additionally, some of these families have special names that you'll need to know. So let's talk about these special families. They are in the main group, Group 1A, Group 2A, Group 8A, 7A, and 6A. So Group 1A are known as the alkali metals. The alkali metals. Group 2A are the alkaline earth metals. Okay? The alkaline earth metals. Group 6A here are known as the chalcogens. Chalcogen. Group 7A are the halogens. And then finally Group 8A are the noble or inert gases. Noble or inert gases. And the reason we give these families names is because we're going to refer to them a lot. Because remember, all the families, anything that's in the same family, is going to have similar chemical properties. So for example, lithium behaves similarly to sodium and potassium and rubidium and cesium. Helium, neon, argon, krypton, xenon, all these guys over here behave similarly. They don't react very well with anything else, or some of them don't even react at all. So the families that we're going to talk about a lot are those guys that are named. The alkali metals, the alkaline earth, the chalcogens, the halogens, and the noble or inert gases. If I say, give me an example of an alkali metal, you should be able to give me an example of the alkali metal. So we've just scratched the surface of all the things that a periodic table can tell us. We're going to come back to it in Chapter 8 after we learn a little bit more chemistry and how things react. So as a review, the things that are very important about the periodic table so far is how it's arranged by increasing atomic number or increasing number of protons. It was put together by Mendeleev, but there was also another guy who came to it on his own. We don't talk about him too much, but the guy named Lothar Meyer. The rows are the periods. The columns are families or groups, and they've got those names. Remember, group 1A, group 2A, group 6A, group 7A, and group 8A are our special ones that we need to know the names for. There are nonmetals, there are metals, and there are metalloids, and we can break up into two basic components, the main group and the transition metals. Now, I didn't talk about it, but that bottom part are also known as the inner transition metals, or the lanthanides and the actinides. We're not going to spend too much time on those guys. They've got some really strange chemistry. We may talk about a few of them, but we're not going to spend a lot of time on the inner transitions. So what is it about the elements that makes it so interesting? Well, it's how they combine. And the first method of combination we're going to talk about is through the formation of ions. The second one is through the formation of molecules. The difference between an ionic compound and a compound made out of molecules is that a molecule or a molecular compound does not have charges, whereas ionic compounds are built from charged particles. So an ion is a charged particle. There's only one way you can become an ion, and that is to gain or lose electrons. You never change the number of protons, because if you change the number of protons, you change the element identity. Now, if you are a positively charged ion, you have lost electrons, so lose electrons. If you have gained electrons, you are negatively charged, and you have the names cation and anion. So cation is a positively charged, and an anion is a negatively charged ion. So positively charged, negatively charged. Now we can talk about ions in terms of many different ways. Let's talk about monatomic ions first. Monatomic ions are those ions that contain only one atom. These are pretty common. So for example, like sodium chloride. We know the formula for sodium chloride is NaCl because we've seen it all over the place. These consist of monatomic ions. The monatomic sodium cation we can write as Na+, and the chloride ion, which is a monatomic anion with a Cl-. Let's contrast that with polyatomic ions. Polyatomic ions have multiple atoms bonded together and that are going to act as one thing. So let's take a look at something like baking soda. Baking soda has the formula NaHCO3. In this, we've got a polyatomic ion. The polyatomic ion here, HCO3, is an anion, a polyatomic anion. Most of your polyatomics are going to be anions. And there is a list that you should be familiar with. And that list is on the Learning Resources page for Chapter 2. When dealing with monatomic ions, we can sometimes find the charge of the ion if we take a look at the periodic table. Now, this I don't quite agree with completely, but it's a good starting point. What I want to show you is there are some always things in here. So always are going to be in red. The group 1A are always going to form +1 ions. The group 2A are always going to form +2 ions. So 1A plus 1, 2A plus 2. Now I'm going to skip over to the 7A. This is always going to form a -1. 6A are going to form a -2. Now the 5A, here, these two are going to form -3 as monatomic ions. So +1, +2, -3, -2, -1 down the other side. And there are just a few other ones that fall in the center of the periodic table that are always going to be easy to find. And that is what I've drawn here. The silver ion is always going to be a +1. Always a +1. Now, there's only one of them in that family. That one +1. Zinc and cadmium are always going to be +2. And there's 2 of them in that family. And finally, in the 3A, aluminum, gallium, and indium here are all going to form +3s. And there are 3 of them. It is really important that you know these charged ions and what they are, because these are always going to exist in the same charge. Group 1s will always be a +1. Group 2 will always be a +2. Silver will always be a +1. Zinc and cadmium will always be a +2. And so on and so forth. Because we need to be able to contrast those to things that form multiple charges. Like chromium. For example, chromium can form a +1, a +2, a +3, a +4, a +5, or a +6. 6 different charges. And they all have different chemistry. So it's very important that we know when we only form one type of ion. And finally, we're going to talk about the polyatomics. There is no relationship that is easy to define from the periodic table. This is a straight memorization game. You must memorize ion formulas, their name, and the charge. This is super duper important. Super duper important. And that list of polyatomics you should know is on the Chapter 2 Learning Resource page. The reason this is so super important, remember, we talked about chemistry being like another language. And knowing these polyatomic ions and their names is like knowing a few words. Can you imagine if you were studying Spanish and you had to look up every single word in a sentence in a dictionary? It would take forever. You have to know some basic vocabulary. This is the basic vocabulary. So, once you get the polyatomic ions memorized, you'll be well on your way to being able to name compounds. And I highly urge you to take a look at all the nomenclature videos that are already posted online.